Well, I guess it's time to get started. It's always challenging to do a talk just after lunch, so here's the deal. If you're a technical person, you can play Candy Crush and whatever, because the first part of the presentation, it's about a security program, and there's no code and terminals. But then there will be terminal time, so you can stay here, and otherwise you can play Candy Crush after. So this talk is about lessons in auditing cryptocurrency wallets. There are a lot of things that are specific to cryptocurrency, but there are obviously a lot of things that are application security. So I will try to highlight what's kind of specific and different. My name is Luca Carettoni. I've been doing application security for a while now. Moved from a software developer to a security engineer, actually before a consultant, then a security engineer. When you go to consultant, from consultant to security engineer, you realize how hard it actually is to secure things. And you appreciate the work that other people are doing to do secure systems. Moved in a bunch of company before making my own company with another co-founder. And kind of starting a new journey. And this talk is really about what we are doing as a company. We are focused on product security testing. So we test software that other company makes, and sometimes software as a service. And a lot of the customer are obviously in the fintech cryptocurrency space. There is a lot of attention to offensive engineering, but then again, there is not much attention on you find a bug, okay, how do you fix it? And so we try to kind of fill that gap, and it's been working pretty well. So my talk is not a crypto talk, and actually when you are thinking about breaking cryptocurrency systems of any kind, crypto bugs may not even be involved. We had a few talks from JP, they are focused on crypto. And when we do assessment, in some cases we don't even touch the crypto part, because that's usually segregated to different type of assessment. And the reason for that is there are a lot of other things that can go wrong in a crypto system or any type of system. So I like to use the comparison of current and electric wires. Attackers, are really opportunistic subjects, right? Are opportunistic actors. So as the current, they will take the path of least resistance. And that's pretty much, true, whether, the path is your support team that opens untrusted attachment, or your application is exposed on the internet and has some vulnerabilities. So while I will be focusing on application security and vulnerability, and particularly on the security testing space, you have to think about the overall, your circuits, that is your company. So in security world, we are known, we always talk about the weakest link. Just keep in mind that what I'm talking today is really just a small thing. It's one of those rings. So how you build a security program, and I don't expect you to read this stuff. This is from BSIM, which stands for Building Security Maturity Model. It's just a model to understand how mature a company is in terms of information security. And the bottom line here is it's complex, right? You have a lot of controls and a lot of things you need to do. Some of them are technical control, some are not. And so how do you start and what do you do when you are, for example, a cryptocurrency company that is approaching the market? I've been trying, in the several years working in internal teams to kind of distill all those controls into smaller and consumable points. And I think, if you really want to think at the high level, good application security is basically people, processes, and technology. And so I will be spending, a bit of the presentation on people and processes, and then, all for the time on the technology side. So people, it's something that technologists or like security engineers or engineer of any kind, they kind of dismiss usually, but it's obviously a very important component. If you are in the software development space and you think that you have a talent shortage, and you look at the information security field, then it's really a problem. So those are data from 2015. So my boss, when I was at LinkedIn, did a study on using the LinkedIn data on what's the talent shortage for information security. So back then there were 189,000 people that had profiles that had somehow keywords that could be associated to InfoSec. Pen tester, security system engineer, or things like that. And obviously this is a bias because the social network is big in the US and not so relevant in other countries, but it's still a good representation. And what's interesting is that actually only 10 countries make up 75% of the talent pool. So this is a massive disparity on capability and countries. And then what's more catastrophic is when you compare the demand with the skill set. So the 4-to-3 is for 4 people that have active job, there are 3 jobs posted on LinkedIn. So that means that unless 3 of those 4 people change job every year, it's just basically you're not gonna make it. Just for comparison, I posted Italy, my own country. There was no data on Poland, where there is job stability because there are not many jobs in IT security, but at least back then. But generally speaking, in US and highly kind of technology-centric countries, you will have those numbers. So to close the people part and go into more technical stuff, people are really the most precious asset. Like if you need to decide invest in technology, tools, or whatever, hire a good security engineer. That's I think the best advice I can give you. So they're difficult to find and hire. There is a rule of 2% for product security team, where a small and medium company theoretically needs to have 2% of the 2% of the workforce needs to work or be related somehow to the information security team. Of course, almost never happens. So you're lucky if you have budget and you can make it for 1%. And then it's incredibly difficult to retain people. So the average tenure of a CSO, still for the previous research, was 4 years. And if you think about like some of the goals that the information security program has, 4 years is really nothing. So let's go into processes. And for processes, I want to use something that I found particularly interesting. It was published a few weeks or maybe a couple of months ago. And that's the idea of 6 buckets of product security that Colin Green came up with. But I think it's personally, I think it's better titled, the 6 buckets of the security bugs. So the way you want to think about these buckets is if you have a security bug, so a defect in your software, your bug is in at least in one of these buckets, right? So if you do proper design, or for example, you use a web application framework that does contextual encoding, and you killed all the cross-scripting XSS in that way, well, the cross-scripting vulnerabilities are into prevented bucket, right? Because they didn't become code. They were just killed at the root cause. You write software, you introduce bugs, and then you may have security checks, for example, in your CI/CD pipeline, so static analysis or things like that. And so some bugs will end up in the found automatically. And it's great because it's usually cheaper, and once it's set up, it's there. So if you're good at trade-off with false positive, false negative, that's a big win. Then there is a find manually. So that's what a security engineer or people like my company would do. They come in, check the code, spend a lot of days trying to find bugs. We do find some bugs, are great bugs, but they are like a small minority. And it usually costs time and costs money. You want to have it because this is the last chance to get the bug solved before it goes out. But it's less efficient, for example, than found automatically and prevented. Then the product goes out. And again, this applies to any product. It goes out, and there will be people reporting to you vulnerabilities, whether it's people because they are kind and they send bugs for free to your email address or through bug bounty. the vast majority of bugs, it actually goes never found, or at least that's my intuition. So there is a set of bugs that people don't search or cannot find, or they are too nested, and they will be there. And then there is a percentage that eventually will be exploited for malicious purposes or abuses. So what should be your goal? And as any company producing software or managing a service, I think this slide should kind of be your way of thinking when you think, okay, does this activity or this tool or this person, do they actually help me to get a secure product? So ideally, you would want everything prevented. It's not possible. So you may think about something that you can add to the found automatically. So some tooling that can help there. And then it's okay. You will have a security team. You will have consulting. You will have other resources. So you can have the last part of bugs finally found by manual inspection. Now, my experience in both internal team and consulting is very different. Usually, that's the representation. So, mature company would have a lot of prevention, for example, security design, and we will talk a bit about that. A little bit of the bugs are found. I mean, useful bugs. I'm not talking about code. Things are not nice in code, or spacing and tab fights or things like that. I'm talking about security bugs. Security tools in the CI/CD pipeline will find your low-hanging fruits. They will not find, whether you use dynamic scanning or static analysis, they will not find the interesting and most complex bugs. Not to mention business logic or things that are not even possible to be found by these tools. Then, depending on the software maturity and the company, you may have resources that actually finds bug manually. Bug bounty are increasing the bucket of the bugs that are found externally. But the recent hack, a few days ago, shows that you can have a bug bounty, but still doesn't mean that you don't have bugs or your company won't get compromised. As I mentioned, a lot of bugs will be in the never found, and then there will be a small percentage that will actually be exploited for bad things. So this is kind of the reality check from you would want to act. So my takeaway, the things I want you to take away from this bucket stuff is you always need to think about shifting stuff on the left, right? So translate these things in numbers. And you can actually make good metrics around that, right? You can see how many bugs are found in CI, how many bugs are discovered by the consulting firm, bug bounty, how many incidents you have. So that's the last bucket. And then kind of share those metrics and prioritize. And so let's talk a bit about what can you actually do in practice. Because this is nice talking, but then when you're actually on the job, you need to help people or your company to secure the system. What do you do? And so there are a number of people that are trying to promote this idea of reducing attack surface, which in short is, clean your code, delete your code, do house cleaning. If you have an application that is parsing, different file formats, why do you have to have file format parser for all the files of the universe? You just care about the one you support, and so you can focus your attention there. If you have services that you don't use, don't expose those on the internet. Things like that. And those are very impactful actions where it takes time. I mean, even cleaning up code, even deleting code is work. But it has immense, it has a return that I think a lot of people underestimate. And then, of course, this, secure design. So as engineers, I mean, we are expected to build things. I personally feel like we are expected to build things that are secure by design. We should not. It's our responsibility to make sure that things just work and work in the best way. And best means, reliability. It means it does what it promises, but also it's secure. There are different degrees, of course, and company may not promote or facilitate that type of thinking. But I mean, designing system, it's really important. Designing system with security in mind, and it's easier, it's easier said than done. But I think we are, overall as an industry, we're getting better, and consumers are valuing privacy and security a bit more. So that's driving budget, and so it will help. But now, don't be too much into security design, because then there is Ian saying, if you have enough bug, basically your security design is relevant, which is absolutely true. And I'm going to give you an example. So let's say that you really want to secure a system, and you start setting up a server that is not exposed on the internet. So let's say you have a firewall, or if you're an Amazon security group, and the login is, you check, and there is even rate limiting for, so there is a login and there is rate limiting for brute forcing, all good. Then you just need a sysadmin that misconfigure an AWS role or a firewall to expose the system, and then you just need a bug like a SQL injection or anything that could allow the compromise. And so, yes, you did design the system in a proper way, but then a chain of bugs it basically made the design irrelevant. So don't think that the secure design is enough. And so to go into the testing part, right? And this was, because that's what I mostly do every day, is, okay, we moved from waterfall where you could tell to a team, okay, stop, I need to do security testing, to something where people are releasing a lot of code, and so there is no more time to say, okay, you need to wait two weeks. And I can see that also with our customers, where there is this internal pressure to release things, and security cannot be a blocker anymore. And so we are slowly moving, and I think a lot of us understood that the full scope pen test that it was done once in a year, it's not possible anymore, especially in certain industry, like for example cryptocurrency, where you want to experiment new features pretty quickly, and then if they don't work, just retire them. And then so instead, there is something I like to call tactical security testing, which is just focus on a feature, right? Just focus on a small block, and then iterate from there, and get into the new things. But then the question becomes, okay, how you pick the fight, right? How you pick your target. This is not the only way you can do it, but it's something I've done in the past and works pretty well, is you use the same way that you do risk analysis, like a risk matrix, but you use for security testing. So you can say, okay, I need to evaluate the impact and the likelihood. So if a system or a features goes into the upper right, well, that most likely my priority for testing. So in practice, how do we define likelihood and impact? So likelihood could be, for example, the service exposure, right? So if you have a system that is only accessible via VPN, then obviously you don't really care, or you may care once you are sure that the other things are properly secured. Software maturity. I mean, if you've done a lot of testing on some software, that's great. You may want to deprioritize those softwares. If you use secure frameworks, those are things where classes vulnerability are already cut and don't exist anymore. Or you can also think in terms of reaction. So if you have system where you don't care about detecting, fixing vulnerability, because you know that you have immediate response in some way, for example, logging or alerting or some automation in the application, then it's generally okay to deprioritize, because even if there are bugs, you know that you can respond quickly. So how you evaluate then the other axis, so impact. One way is to think about the value of protected assets. So if you think about the traditional banking industry, and I think this applies a lot to cryptocurrency, in the 16, the 17, there were a lot of robbery, and the reason for that was there were banks where all the money was stored there in those giant places. And so a single robbery would actually benefit a lot to the attackers. And then we move to the small branches and ATMs, where you can net a few $1,000s, but that's very different from a big robbery. And so we have the concept of hot and cold wallets and things like that, but isolating and protecting assets based on value or reducing the value of the assets, it's a great strategy. And with that, you can then prioritize what to test and what to look, where to look for vulnerabilities. Beside the reputational part, for example, you may not care about certain bug severity. I mean, if you work for a big internet company, I can assure you, you will get a lot of emails and blog posts on vulnerability that have close to zero security relevance, but they somehow impact the perception of security. But if you truly care about this security and the privacy of your user, then just focus on what really matters, right? So don't focus too much on what the blog post you will get or the negative press of certain feature you're making. And then interesting thing is prefer code coverage versus attack coverage. So the idea here is that if you're testing an API, for example, you want to make sure you actually tested all the endpoints for specific classes of bugs that are inside this game over bugs bucket. And then finally, one consideration around kind of on-field advantage. So if you develop software, there's something that could be useful to you is bugs tend to cluster. So a very successful strategy is if you get a report or you discover a vulnerability, look for bugs, for the same bug inside your entire code base, or look for different bugs inside the same file. Because it's either something that people don't know or you haven't taught properly to your company, so a lot of developers will make the same mistake, so it will be spread out, or is one person that made several mistakes in a few files that he or she was working on. So when you get a bug report, that is a security report, spend extra time to do the cleanup, and I can ensure you will actually kill a few bugs with that. And of course, invest in frame level protection and things like that. So takeaway for the process part is release more code means you need to do continuous testing. And so forget a once in a year pen test. And I gave you some recommendation on how you prioritize then your testing part. So let's go into the technology part. So there is no security blinking box. I wish I could invent one and sell. The best we have is security automation, which is nothing else than code and scripts that can do stuff for us. It does help to have some of the controls. For example, if you find a vulnerability and you can search in your code base, and you don't need any expensive static code analyzer like grep or any tool that would do a basic sync to source tracing will be more than enough. Can actually find useful stuff. But yeah, that's that's the level of technology we have as of today for security automation. It makes sense to invest, but don't expect that the tool that you build or buy will solve the problems. It won't. And then we talked about bugs, we talked about buckets, and there are different type of bugs. And there are bugs where I don't think you can ever find with a tool, or you can find with a tool after you've found one manually, and then you can go back. But generally, it's not something you can have a tool that will do and will find all the bugs. And so with that, I'm going to give you some examples of real-life bugs that we found when testing cryptocurrency system. And they're kind of like different, but you will see kind of what's the common things, which is some are easier to detect and some are probably impossible if not through manual testing. So there's this thing called CORS. If you don't know, it's a mechanism used by browser technology to bypass the same origin policy in a controlled way. So same origin policy is the mechanism that prevents so I don't know, Google.com or and Yahoo.com to have separate entity inside your browser. So cookies are separated, and the interaction between your client and the website is isolated. But sometimes people do want to access things cross-domain. And so there's a nice standard called Crossorigin resource sharing, where basically it's the server authorizing the client. So this is the technology the browser understands to allow certain, to basically make this control not as strict as the pure same origin policy. So the client will send a request, and the server sends back two headers in this case, access control allow origin, saying, okay, this origin can access my content, it's allowed to access my content, and then there's a directive, in this case is appended here, allow credentials, which means that the browser will also send cookies, because that's normally not done with CORS. So what we found in a crypto wallet, and again, it's nothing to do with crypto here, it's purely a misconfiguration of the CORS, where basically the crypto wallet was using a framework that requires some configuration, and there was no configuration, and so the allow origin were basically set to an empty list that would end up being a null origin, which is just considered by the browser as a string, and it also had the allow credential true by default. And so that means that an attacker can actually make a null request, like a request with a null origin, using a sandbox iframe. So those are kind of the two ways you would exploit this type of misconfiguration. So you have on an attacker page, so that's something that the attacker fully control. You have on number one, you basically have a page that just creates an iframe and calls another page again on the attacker control, which is displayed on number two. That just makes a request to the vulnerable server. You see where it's request.open. The origin will be set to null because of the iframe sandbox, and so the data, the header that is sent back by the server will match the request header, and so CORS is allowed, and as a result, the attacker web page can then read the content. Completely different bug. Again, this is like I'm doing like a showcases of things that went wrong. We tested a corrosive exchange where there was a concept of contract, and basically you could negotiate a rate, and then we noticed that actually contract timestamp was not checked. And so basically the idea here is that the attacker could negotiate an exchange and then decide, depending on the price of Bitcoins, to sell or not. And so it's kind of a situation where it's a business logic bug, no tool will probably find, and it's an opportunistic type of bug, right? But obviously it can generate money. So, or things, for example, you don't expect. So in Python, if you use asserts, when you compile to bytecode, so you have pyo file, assertion are removed for speed, and so and optimization. So if you use assertion for security, like this case, where you actually check the addresses belongs to the same deposit address, then it's pretty bad if those pseudo if statement goes away. So never rely on assertions. But again, just another example that you don't need crypto to break cryptocurrency systems. This is another example of a function that is not insecure by itself, but the way people use it and understand it's not always that clear. It's PHP OpenSSL verify, which basically just a function to that is baked by the OpenSSL to verify that the signature of some blob of data is correct, and it's signed by a proper public and private key. And so this is just a contrived example of something we found where there was basically a selection of whether it was possible to verify or not the signature using OpenSSL verify in a if statement. And so if you look at this code, it kind of looks okay. But then if you go into how this OpenSSL verify actually works, is there is a case when the function goes into an error, goes into an exception, that returns -1. But -1 in PHP, as you can see there, is actually evaluated to true. So if we go back to this code, then if OpenSSL verifies true, then you actually verify the signature. So the question comes to, okay, can we generate an exception? And so we have 7 minutes, but let's see if... so I just made an example on my personal website. So in this case, there was selection, and this is this is a much easier example. But the idea behind the bug we found was, as a user, you could select a key type. Key type is a property that is used when you want to generate the public key, public-private key pairs, and they are just integers, right? So if we just try this endpoint. And we, I don't know, just put it 0. We see that the signature validation failed. And then if we add an invalid signature, because in this system, for example, one of the key type is not supported, like we did not load the modules, and actually this is the full configuration of PHP. You have a situation where a perfectly fine endpoint with key type 1, which I don't recall exactly what is the key type, but it's basically not supported, so it will trigger an exception, and then unrelated from the data of the signature will always, because of the -1 evaluated to true, will always bypass the signature verification. Another fun example, it's always fun to make money from nothing. It's a custody system that is sold to a company that manage Bitcoins. We found a lot of validation on withdrawal, but actually the withdrawal account did not have validation for negative withdrawals. So basically you could fake a negative withdrawal and basically make up money. Again, super simple bug, but those are the things that you won't probably find. Or, I mean, yeah, it would take you, you need to know the bug to then write some code that would actually find it properly. Or otherwise you have hundreds of false positive. And then finally something that to me it's like when I don't have any idea for bugs, I usually go to this bug. A lot of websites from cryptocurrency to non-cryptocurrency have this type of problem, is password reset token leakage through referrer. So the idea is that when you do a password reset, you generally have a reset token, and the reset token needs to be received by this website to validate whether you are the correct user and kind of authenticate yourself before resetting the password. But that's usually for the ease of user just clicking on a link. It's part of a GET request. Either it's a GET parameter or it's part of the path, and that token gets sent to a lot of places. So I made a kind of again a simple example here. So we have a stupid example. We do send a reset password, and okay, the email is sent, right? So let's now imagine that, and I'm gonna open the inspector to kind of see the network traffic. So let's say that these endpoints will expect a token. So this would normally be the link that you have inside your email when you click on, yes, I want to reset the password. So the landing page that is the one receiving this request that is usually what tell you, okay, you can now enter your password. This is generally not a white page. This has generally CSS and JavaScript. And so you can see here, for example, I'm loading jQuery from the Google CDN, but then the referrer will actually contain my token. So that means that access log on Google server, and you may be okay with Google, but we're using a lot of third-party services and JavaScript and images, may have dozen of access token of your users to their web server. And of course, there are a mitigation. For example, if you allow one use only, it's a race condition, like someone needs to be there in order to use the token before the actual user is using the password. But there are also systems that would allow multiple tokens, or you can also think about someone trying to reset the password and then giving up because receiving a phone call or whatever, right? So this is a generally problem, and it is a problem also depending on what are the third-party services you're sending your token to. So with that, I think the kind of two useful things I hope you can bring back home is people and tools are complementary. So don't buy the blinking machines that solve the security problem, which may be obvious, but sometimes it's not, because it's very tempting to buy something that solves all the problems. And then if you're thinking more practically on, okay, how do I make my security testing and overall my bugs management better, is, okay, move your bugs as much to the left as you can. And so, for example, if you get an externally reported bug through a bug bounty, well, then try to write scripts or try to look in the code base for similar code patterns. That means you're moving these things either back to human found or auto found. And so every time you're moving something in one way or another back to the left, then you're kind of winning. And with that, if you have any question, I'm more than happy to take them.